Morning, everyone. My name is Thiagu Palaniappan with TriStar. So welcome to another Creo webinar. Today's topic, we thought of just doing an overview on the different surface modeling paradigms in Creo Parametric. This webinar will be recorded and it will be made available in our resource center. So before we go through the agenda, real quick, some of the promotions that we are running this quarter. First, on the Creo simulation and analysis solutions. So if you that's running through the end of June. There's also an offer on training, on the virtual training, up to 60% off, as well as on the MatCat solution. There's a 36% off through June. Now, some of you may have already registered for PTC LiveWorks. That'll be happening in June in Boston. And if you want to check out our website, you have the details about this event, and our PLM experts and the team will be there to help you with any questions. And just a reminder, you may have seen our Creo webinar series, and in August, we're going to be doing a webinar specifically on the technical surfacing or parametric surfacing, which many of you may have already used, and then the Freeform surfacing or ISDX or interactive surface design extension or style, and then there is FreeStyle, right? That's new to Creo Parametric. So those are the three main, different options you have within Creo Parametric when you want to create a surface model, right? It depends on your design intent and what inputs you have. Are you an industrial designer? Are you a design engineer or mechanical engineer? You could try to marry all these. So that's kind of how typically, when you design these type of products, you may want to marry these different paradigms where you want to have dimension control at the same time, very high quality smooth surfaces that's probably organic in shape, but still the ability to change them with dimensions, right? During the presentation, all of you are muted, but towards the end, we can have a Q&A session. So if you could please start typing in those questions in the GoToMeeting chat or question area. I'll try my best to get to those as soon as I can towards the end. Really quickly, before we talk about the different paradigms, the nomenclature, right? This is something that you may have heard quite a lot when there might be a surfacing guru or an expert in your company, or maybe you might be a new user in surfacing, but you always hear these connection types like G0, G1, G2, G3, the type of surface, right? How is it classified? Is it a Bezier or a B-spline or a NURBS? What type of polygon controls that surface? That would determine, is it a third order, a fourth order, or a fifth order surface, right? So really, if you think about a surface model, right, you could create a surface model on its own using curves, right? That's what we normally do. However, many times what we call hybrid modeling, where you may want to marry the solid modeling and surface modeling features in such a way that you're working on a very complex area or a complex casting where the solid feature simply fails. The round and the draft, they just don't work, and you may have to do some patchwork using surfacing, right? So really the skill comes in making smooth transition from one surface to the next, right? Really the goal is being to create a very smooth quilt, right? When we say quilt in Creo, as you know, we are talking about a group of stitched surfaces where you can select that quilt. Depending on if it's open or closed, you can solidify it, thicken it, what have you, right? Now, as for the connectivity itself, right, whenever, like you can see in those images there, when you have two curves, that's sharing a common point, right? We call it G0. So essentially, a surface created through those two surfaces or through those two curves create two patches. However, what about the continuity, right? You don't have tangency, right? So that's G0 continuity, but sometimes, most of the times you do need tangency, right? At least G1 continuity, wherein all you're saying is the two curves or surfaces are going in the same direction, right? That's like, as you can see in the second image here, right in here, right? But then G2 continuity is one level higher than that, wherein you're making sure that it's going to be curvature continuous, not just tangent continuous, right? So maybe you're working on a casting, it's an internal radius. You don't have to worry about curvature continuity. You could see how there's a huge gradient in this right here, where you could see the gradient wherein the curvature changes from a small value to a high value. So sometimes these might be important, especially on consumer products or any components that are used outdoors, right, wherein you need to worry about the aesthetics, right, maybe the fluid flow. It's more from an analysis standpoint as well as from an aesthetic standpoint, where you do want a curvature continuous surface, right? Now, you could also create a G3 continuity wherein you're not only making it curvature continuous, but you could even see in this one here where I'm making sure that the change or the acceleration of that change in curvature is also smooth, right? So that's kind of like the highest quality possible, right? And many times, instead of using G2 continuous surface in the industry, as you know, they may be asking you to create a Class A or a Class B, Class C surface. So when I say Class A, Class B, or Class C surface, we're really talking about, right, the roots from the automotive industry, as you can imagine, right? So that's when we start talking about Class A, so when I say Class A surface, it could be something that you're using outdoors, right? So that's when we call it Class A. And a Class B is maybe I don't worry about curvature continuity. It's the next level. It's one of the interior surfaces where I don't have to worry about curvature continuity, right? So like that, all those roots are from the automotive industry, but within Creo Parametric, you do have the ability to add these, depending on the design intent and what type of products you want to create. You could choose to spend some time increasing the quality of the surface, right? Now, you can also control the order, right? For example, with Creo Parametric 3.0, when you do a boundary blend, you are using a 5-degree, it's going to create a higher quality surface compared to the previous releases. So CAD vendors keep improving the quality of the surface, right, depending on how you create the curve. I always say that your surface is as good as your curve. So once you're good at creating the curves, right, for example, in this picture, you could see 3 polygons or 3 lines of my polygon controlling it. So that's a 3-order surface compared to a 5-order surface where I have 5 lines in there, right? So all those, it depends on how you want to modify the topology of the surface using those curves or points, right? Now, technical surfacing is something that they're built into Creo Parametric, right, where you could use your traditional familiar solid modeling tools like variable section sweep or a swept blend or a boundary blend or a filled surface, etc., where you are trying to create, control your geometry, your resulting geometry using some parameters and dimensions, right? So that's kind of what we are. If you're a design engineer or a mechanical engineer, typically you do want to show some dimensions in the drawing. You have to have a design intent when you make a change to the size of that cover. You want the surface to update. So that's what we call technical surfacing or parametric surfacing, right? I mean, you could use various relations like trajpar, right? You could even use graphs to control your sweep. So this is something that's purely math-driven, or I should say dimension-driven, right? It depends on what design input you have, right? So if you were to create some really complex shapes, right? You're working on an impeller design. Obviously, the aerodynamists might have given you the curves, right, based on their analysis. Now it's your job to create the surface you would be using technical surfacing, right? Now, when would you need interactive surface design extension, or ISDX, right? It's also called style. And that's when you need really highly organic shapes wherein you want to be more flexible, and it's more for an industrial design type tool wherein you are able to quickly create 3D or 2D curves. It's a super feature in your model tree where you're essentially using splines, right, 3D splines to create your surface, and you can control the curvature. It's like one super feature where that could have that entire surface or that eyepiece that you see there. Now at the same time, you want to make sure it's driven off of some parametric curves. So that's very important, right? So when I create these very cool looking shapes, I just still want to make sure it's driven off of a parametric curve or a sketch. You could do that. So essentially you would be marrying these two. It's more like to get a high quality surface that's curvature continuous in all direction, I would use ISDX. At the same time, I have quick flexibility in changing the topology of the surface by quickly generating a 3D curve off of that surface, making it smoother compared to my boundary blend that I may be using in technical surfacing or regular parametric modeling, right? There's also FreeStyle that PTC introduced starting the Creo platform. Some of you may have tried it, but so this is a very rapid way of creating your surface models, right? It could be that design that you see there at the bottom, the bottle there. Start off with a primitive, so it's more like clay type modeling, or I should say subdivisional modeling, wherein you are using a control mesh to quickly create the shape that you want. So it's very helpful at the concepting stage. This can also be used in conjunction with your existing parametric curves. Now, how good is that bottle to me if I don't know the size of it, right? That's very important to me. So I may have a skeleton, or I may have a curve. I may have some frameworks or 1:1 scale images that I would like to bring into my plane and then start using my primitive shape and then start trying to match it as close as possible to create a quilt. So in normally a surface like that, if you need to use technical surfacing, it would take some time to add boundary blend or swept blend, or different types of features you could use, but it'll take some time to build that. But this is, like I said, for rapid surface exploration, if you design exploration kind of situations where you want to quickly create a concept and see how it looks like and then go from there, right? So that's FreeStyle, which is included in Creo Parametric starting 1.0 and 2.0, and as well as in 3.0. Some of the, a few options in surfacing that over the years, I thought of sharing with you that some of them are new, some of them have been there before. Like the Untrim Surface, very helpful when you bring in imported geometry. It could be even a native Creo surface, but there's a way to extrapolate a surface patch to its envelope or to its original domain definition. Very powerful, right? You're creating an associative copy. When you do a copy-paste of a surface patch, you can see how it's essentially extrapolating that to its original domain, as you can see here, right? So right in here as well as here, right? So that's something that I may want to use when I import geometry, maybe for repair purposes, right? I don't have the original geometry that they used in their CAD software, but they gave me the final quilt, but during translation I've lost some data, and now I'd like to extrapolate from there. So it's really helpful, and you just do a copy paste on that surface patch and you get the option to untrim it, right? And then you can start tweaking that as required, or even use a style curve and then start adding additional control on this. You can also check if there is a G0, G1, G2 continuity in your surface, right? So this is something that we talked about earlier, where you have these different levels of continuity, right? Are they just sharing a point? Are they tangent? Are they class A or curvature continuous? So rather than doing separate porcupine analyses, right, or shaded curvature analysis, you are essentially selecting an entire quilt or even just two surface patches that you are interested in knowing if that boundary is just to know about the details of the continuity of the two surfaces. You could do this connection analysis, right? And one nice little tip, which some of you may have used, is the ability to quickly convert multiple patches into one single surface. Now, this is very important both from a manufacturing perspective as well as from an aesthetics perspective, where you're getting rid of those patches that you see here, right? So if I were to go, so you can see how these, I got like two patches here, and here I just got one single surface patch. The way that I'm doing this is essentially converting my curve, right? So when we designed this original curve, or when we sketched this curve, I'm having quite a few entities, right? A straight line, curve, portion, etc. But I could convert that into a curvature continuous, or a C2 curve, and then do the blend so you won't get this. So it's a nice little feature when you do the copy paste to create the composite curves. And also control points, right? If you were to use technical surfacing, when you add your boundary blend curves in first direction and second direction, like in this model, you could see how by default what I'm getting is quite a few patches. Now that's going to might create an issue when I try to thicken the surface and solidify it, right? That's not a clean surface. How do I get rid of that? Yes, I could add control points, right? I could add a few control points here and say I want you to just use that. Many times it's just a matter of automatically using the software's automation tools, where you're going to say, I want you to map arc to arc automatically if available. And that's something, if you try it, you'll see by default itself, you don't have to spend a lot of time adding these control points. You can, of course, change the control curves manually if you'd like by adding additional points, but by default, you can at least get a good surface, good continuous surface there. Now, all this is depending upon how you created the curve, right? Like, your surfaces are always as good as your curves. How was this curve done? Is it done separately? Do we have a continuity here? Do we have a continuity here, etc., right? The surface feature creation itself is easy, but the biggest skill will lie in how you create the curves. One quick example here on speaking about curves, right? How do you create a 3D curve? Yes, you can import CMM point cloud data, right, into Creo Parametric and generate a curve through those points. However, there are times where you might know the resulting curve in two perpendicular planes, like in two 2D curves, which can be captured as a sketched curve, and then you can simply intersect them without the need to even create a surface for the intersection. So pretty nice tool. So I have these two curves right in here, right? This curve, and this green curve that you see. Those are two 2D curves, and I'm just going to say intersect, and it gives you the compound or the resulting curve. So essentially, behind the system, the software is essentially creating a quilt, right? Extruding the quilt, and then, right, creating and giving you the intersection 3D curve, right? I mean, you don't see the feature there, but that's kind of what is happening behind the scenes, right? And also, there's quite a lot of surfacing tools, but one thing, if you want to create an embossed feature like this, for example, it's very quick and easy on a curved shape or even on a flat surface. You can project a sketch, right? At the same time, say, I want to offset just within that projected area of that sketch, and then add a draft angle and add rounds or make it tangent in there, right? So this is quite powerful feature in surfacing if you have not used it before. Like I said many times, you're thinking your designs are not really organic shapes, and they're regular models, but then the complexity, there are certain intricate regions in the model, like I said earlier, where your rounds simply fail, right? You're trying your best to work with Creo Parametric, and the system is so much math driven, as you know, and it's simply unable to create a solid there. So it might just be easier to convert your surface that's not working into a surface, right, rather than a solid round, convert it to a surface round. So it's essentially, it's not having material inside. So like in this case here, you can see how it's just having all these, you can see one-sided, two-sided edges of the surface there, right? It's all these are surfaces, and then I can work on this area where it's failing. I could add my own curves, for example, and I could do a boundary blend. So it's really like doing some patchwork, merging it, solidifying it. So this is another common area where surface modeling is used heavily, wherein your model itself doesn't have a very organic or complex shape, but then the solid modeling features fail in certain regions, and that's where you have to leverage the surfacing techniques, right? So before we do the Q&A, just a few examples that I wanted to show real quick here. So let's see here. So most of you may have used the technical surfacing. So that's a few tips on the surfacing side, on the technical surfacing before I show you the style and the FreeStyle. I do have a boundary already developed here, right, with a filled surface, but if I want to throw in a boundary blend in there, all I'm having to do is essentially select the entire curve, right, and then I'm just going to select the rest of it. So it's almost like creating a composite curve, which is not done, but I'm doing it on the fly, right? That's what I'm doing here. So I'm just adding curves in my first direction, right? I could have selected them in one chain if it was like done in one curve, but let's say there were bits and pieces that may happen in the real world, right? Many times when you're trying to fix an imported geometry where you may have to just select them using the shift key, you could quickly select these, right? And then this is just part of my filled surface, so I should be able to select the tangent chain, right? Just hover over it, it'll tell you that's a tangent chain. So I got my first direction. I'm going to go second direction and say, there it is, right? So I got my boundary blend done, right? But if I do a little preview, right, and I go to my shaded with edges, you can see the patches. Now, this is really determined by the bad curves that you have here, right? Maybe that's a conic or it's not an arc. But could you, instead of spending the time going into control points, right, and then manually selecting this, you always want to try the piece to piece. Depending, in my experience, I've seen you always want to give that a shot. If that doesn't work, then you can manually spend the time adding. So when you do the piece to piece, more often than not, you see how it will try to create the surface patch to the actual vertices through which you created that original curve, right? Regardless of how many points this might have in the conic, it doesn't matter, right? So there it is, right? You got a clean surface there. And of course, you can go always and redefine, and you can, these little baseball-like icons, you can go and add tangency to the existing surface, right? You can always do that anytime, right? That's something that you want to make sure it's tangent to the adjacent surfaces there, right? And then you would, and this is the one that you're going to go and you would ideally merge all these, right? And you can merge any number of surfaces, and once you merge it, the next step is obviously to thicken this, right? You would go thicken it, right? Add a thickness to it, and so that's usually, right? If you think about it, that's kind of like the workflow on the technical surfacing, right? So whatever I showed you is the technical surfacing side. Now, there are times that you may want to have additional control, like for example, let's say this example here. I have my curves done. You may have to create sometimes curves on the fly to help you or aid in the surfacing. For example, I want to do a sweep, right? Because I do have some guide curves here. So when I do a sweep, I can just use that as my origin and just select these additional curves. And when I go into my sketch, you could see how that's used for my sketching plane orientation, and I'm essentially going to say, let's add a 3-point curve somewhere here. So this is, I'm having more mathematical control. That's what I'm getting at, right? I've really not drawn for boundaries and doing like the boundary blend like I did in the cover model, right? Now this warning, it's pretty nice in Creo interface in 2 and 3 that it kind of warns you compared to back in the days where you have to make sure, whoops, I forgot to add it as a solid. Convert it to a surface. It's thinking it's a solid sweep, but now it's going to inform me that it's automatically converting to a surface, and there it goes, right? So I'm essentially, you see what it's really doing, right? It's essentially, I don't know, for example, these intermediate curves and everything, I don't have to build that patch structure, right? I do know that the radius at that location, that's something that is part of my design intent, and I'm controlling it using the sweep. Now, I could always go and mirror this guy, right? I could say, let's mirror off of a plane. And then once I mirror it, right, so now I need to start creating some more additional patches here. It's always a good practice not to use the original curve with which you created the surface. So for example, I have a group here where I created this, you see this group number, sketch 2 group, where I have created these curves, right? I could always hide that. And then it's better to use the natural edge of the surface for continuity. So what I mean by that is, right now I may want to create, for example, a curve through these 2 points, for example, right? And I can make them tangent. Right? I can flip the direction of the tangency, see how the tangency flows in a direction. There it is, right? So I could have sketched that as well, but let's say in this case I've created a quick curve. I could also go and create a curve at the bottom where I want to gain control it with some tangency, right? Okay, so I've done this. Now, my point earlier about not using the original curve and using the actual edge of the surface quilt, right? When you do boundary blends, for example, right? So this is where I'm going to select the entire edge. You see how I'm picking the intent edge of that surface. So if that surface were to get changed, this curve wouldn't fail, right? I'm making it more robust to design changes, right? And then maybe the same thing on the other side. I'm going to say the second direction is going to be from here to there, and I'm going to just make it tangent. You could also make it curvature continuous if you're interested in a Class A surface, provided the curves are curvature continuous, right? Sometimes we'll try to make the curves also curvature continuous, but you may have to do that before setting it to a surface continuity on the curvature side or making it G2, right? So just to show you, so these are the options that you use in the technical surfacing side, right? Now, how do you get rid of patches? For example, let's see here. If I have a geometry like this, right, where you could see currently I do have these surface patches in there, right? So these are, I'm talking about these guys and these guys here, right? So I probably don't need that, and I need to, so let me go back here and just have it take a look at the original curves, right? So this curve, if you think about it, the way it was done is using line curves. You can see how it's made of these multiple entities, and that's why, now you know why the patches are. There was like a tangency point, which makes sense why it created a patch through that, right? It's trying to blend that to a straight line, right? And this may have additional points, right? And that's how it got it through. Now, so currently when I do a boundary blend and say, okay, this guy goes to blend to this guy, you see how it creates those natural vertices convert into patch lines. Now, to avoid this, what you could do is you could simply copy paste that. So I'm selecting it, doing a Control-C, Control-V, right? And I'm going to convert it to an approximate curve. So when I say approximate, right, I know this is where we get, as engineers, we think about, oh, is it changing the radius, or what is it really doing? At those connection points, it's increasing the, remember we talked about degrees, right, as to how these are controlled using polynomials. It's really converting that from a tangency, from a C1 continuity to a curvature continuous surface, or I should say curve, so that now when I do my, I probably want to hide this guy, so I'm not going to select that. So now when I do my boundary blend between this and this, you see that I don't have any patches whatsoever, right? I'm in my shaded with edges, and so that's a nice little thing. When you have, it's like when you create composite curves, you do have the ability to make it approximate where it's still maintaining the radius that you want. However, at those connection points between the arc and the line, it's changing the degree in such a way that there is a gradient in the curvature, right? So thereby making it curvature continuous, right? And also the untrim that I was talking about earlier, wherein you could select any of your surface patches, right? So I do have this quilt, and let's say I want to select, this is done, let's say it was imported, it was done in another CAD system, and I'm having to, I need to know the original domain through which they created this patch. So in Creo, I do a copy paste, and while doing the paste option, I can untrim to its or an envelope, right? Or I could say untrim to its original definition. As you can see here, when I do that preview, you see how it even, this is something that's huge when you fix imported geometry, in my opinion, right? So that's, I wish we had it back in the days, but it's there in the current release in Creo 2.0 and 3.0. I mean, you do have this, Creo 3.0, you have this untrim. In fact, you could even untrim the entire quilt, and I just showed you a patch. How about copy pasting the entire quilt and then untrimming to the envelope or to the definition? So it creates an associative copy, right? But you see how it untrims to its original definition. So this is kind of how they might have built it. And here I'm able to get that within Creo Parametric, and then I can tweak these and then create a much smoother model if required, right? So this can be done even on an existing Creo model there. Now you can, I know all that I've shown so far is more on the Creo technical surfacing, like it's purely math driven, right? Now if I have to also, let me show you one more example here, wherein very common question I've got from customers wherein I need to create a curve like this, and I know I could use data points to control it, but a quick way to create that type of curve is to, remember I told you the skill always lies in making your curve smooth and accurate so that your surface is easy and smooth, right? So let me unhide these two curves. I've created two 2D curves in two different planes, right? You can see that's in one plane, that's in another plane. And I'm essentially going to select these two guys and simply say intersect. And when I intersect, you see how, so it's essentially extruding, right, this guy, and then designs. For example, let's say that's something that was already done. Let's say I need to build the fender for this component somewhere around here, right? So maybe I want to start, instead of using my technical surfacing, I'll show you the flexibility with which you're able to use style. When I go to style, right, and when I start creating my curve, I first set an active plane, just kind of like your sketching plane, right? Pretty much the same. And you see, it's very intuitive, right? I'm going to go say that's my active plane, and I'm going to just go active plane orientation here real quick. And I can start throwing in a curve real quick, which could be a planar curve, for example, or a free curve. So I'm just sketching a spline. There it is, right? Something like that, right? And I can modify these. So the good thing about all this is when I edit these, I do have tangency locations, as you can see, for the end that I can control. I can make it normal, etc. So it's a purely spline-based environment that you're in, right? There's intermediate points. I can move them around, add additional points, etc. So let's say I got that, and I can also do an analysis, right? I could do a curvature analysis on it, right? And I can select the curve, and you could see how it kind of gives me an idea, right? So it tells me, okay, so I do have some inflection points, right? This is probably okay because it changes direction, so I can avoid, I'm really checking the quality of the curve as I'm building it, right? And I can also leave it on while I modify it. Now, similar to that, I want to set active plane, for example, as one of these datums here, right? So let's say I want to go to the front plane, or maybe this right plane. That's what I want to set as an active plane. And let me go to my active plane orientation here. And I'm able to reference these curves. So when I create my curve, it's again a planar curve, but I'm able to simply select on the curve. You see how it creates a hard point where it's located at the intersection of that curve, right? And I can start creating something like this, right? I can control the curvature of all of this, right? I can move them around. So what I did really quickly is I created a couple of curves there, and now all I'm going to do is do a surface, right? So let's say I want that to add as a cross collector right there, right? So I've added that surface. Now, having done this, I can always go and manipulate that curve. Maybe I want to add a few more points, or I can modify that, and I can use a 4-view layout to do all that. So you can see the flexibility with which you're creating features here. Now, you can have a parametric curve if you want to, and you can drop it on that. Or, for example, let's say you want to set active plane, and I'm going to go to my active plane orientation, maybe add a curve that's going to be something like this. So I just added a 2D planar curve, and I can simply drop it. I dropped it on the surface real quick, right? There it goes. And now that it's dropped, I can go do a surface trim, right? Using that curve. So I could say the curve collector is going to be this guy. And I could say my delete collector, this is what I want to delete. There it goes. So, and I can have a visual mirror off of it, right? So if I have to have a visual mirror and select that front plane, you see what it is. It even gives you an idea. I have not created this. It's just like a visually, it's showing me how it might look like. Now, I might get a sharp edge here, right, which is not good. And that's where I can always go back. You see the flexibility with which I can go back and change that curve. And I can go to that line, and remember we had a tangent line, and I'm going to say I want to make that normal to my front plane, for example, right? You see how it's, so now you're not going to see that sharp point when you do a mirror. So, and then, ideally after, so it's one super feature, as you can see, right? This is something that you would go to your quilt, right? The quilt is what you would mirror, right? You would mirror off of the front plane, merge it, thicken it, right? So that's more of that's the ISDX, right? This style, right? Wherein it's a super feature, spline-based, right? Allowing you to create surfaces using existing curves that you've done in technical surfacing or regular parametric modeling, or create 3D curves or 2D curves done within style, right? You could also use the new FreeStyle, right? So wherein all you're doing when you're doing a FreeStyle is when you create a FreeStyle, remember I told you it's primitive. You're starting off with a primitive, like it could be a sphere, right? It could be a cube, right? It could be any of these, right, as you can see. And once you place it, then you can scale it. There are quite a few controls here, but the user interface itself, you can see how quickly I'm able to add. Like it's based on the subdivisions, right? So I can add, for example, I want to pull that here somewhere like that. I want to probably extrude that now. I probably want to just repeat that command, middle click here to repeat, right? So, and maybe I might want to just select these and again do an extrude. I can tweak individually, right? So for example, I want to just select this surface patch. I'm just using those, and I can control as to the resolution of these mesh, right? I can do that also. And similarly, I might want to rotate this and maybe at some point connect these two, right? I might want to connect it and something like this. Maybe I want to go and rotate it this way. Maybe I want to do some extrudes on it, right? So, and I can go maybe in a view like this, right? Select all of them, and I can just start dragging them around, and you see. So it's quick concepting. You see how from primitive I quickly got here. Maybe I want to something like that, and maybe I want to delete that patch, right? And I can also say, okay, so maybe these two, I want it to be having a crease in there, right? So that's something, and I can add a regular parametric technical surface right there, right? So, or I could just say I want to just remove material there if I have to, right? I could even say I might want to delete material there, and I want to throw another detail. So you could see how it's still creating a quilt. So when I get out of the super feature, right, I am essentially still having one feature, but it's still a quilt. I can do all my regular quilt operations on it, right? Like trimming, merging, right, thickening, solidify, all your surface operations can be done. Now, this was something I started from scratch, and what is the size of this bottle, for example? I know I did it really quickly. What is the size? Is there a design intent here? I just showed you the capability using that example. But let's say many times you do have a skeleton or existing geometry that you want to align it to. So this might what happen in the real world, right? So you do have some existing curves, geometry that you want to connect that primitive to. When you create the FreeStyle primitive like this, right, you get to scale it down, for example, right? You could say, I want to scale this a little smaller here, right? So let's say I want to go and scale it in different directions. I could always let's see here. Let me go to FreeStyle, place a primitive, and I want to make sure I drag all the surface patches there. And I could say I want to scale it, and I just made it a little smaller than what it was, right? I just made it like a little smaller there. Again, you can control all this, right? You can control the increment and the drag increment, etc. But let's say I want to extrude that. And the reason I did this, maybe I want to attach that to this existing geometry, right? So that's where I can delete it there, and I might want to now match those. Now, in the regular surfacing world, how long are you going to take to build some curves, do boundary blends, etc.? Here, what you could do essentially is get those edges, right? And once you get those edges, you have the option to align. It's pretty nice. You can align it to, for example, to that entire surface right there, right? You see how it didn't make it tangent? I could go to my little line here and say, make sure it's tangent. So any changes that happens to it, it's going to be smooth, right? The same thing on the other hand here, right? So I could just rotate it by roughly by 45 degrees, roughly here, and say maybe I might want to do an extrude on that, and then something like this, right? So you see how you're still having your parametric control, but this shape here, it's going to take forever for you to connect these using your regular, you may be a surfacing guru, but it's still going to take a little bit for you to create those. And this is where I think the benefit of FreeStyle is to control, to align it, right? So for example, right here, if I delete that patch, I could do the same thing, right, that I did at the other end. Start selecting those edges of the control mesh. So I'm really using the control mesh here, and I'm saying I want to do a normal alignment on this curve. There it goes, right? So similar, I could do it at the other end, but my point is when you are modifying this, right, if you were to change the diameter of that curve, for example, you see how it remains there. The same thing with my elliptical shape, right? When I do my edit, it is going to keep updating that geometry, right? So pretty powerful, this the FreeStyle feature. So with that, let's see if we have any questions. So if you could start typing in your questions in the chat session. Let me take a look if you have any. Let's see. Looks like we had some audio issues in there. Okay. Okay, the question is, are there any online tutorials for beginners to learn using surfacing features of Creo? Yeah, there are a few in the knowledge base. In the knowledge base, you can, there are a few things in the knowledge base that you could just do a search on the knowledge base on surfacing features, and they have a few tutorials. Also, the Learning Exchange, there are a few tutorials. What resources would you recommend to someone that wants to learn the style or FreeStyle tool on their own? Yeah, again, like I said, just with the technical surfacing, the FreeStyle, to do your FreeStyle, I mean, there is like an actual training, but you can also use your tutorials in the learning connector, or I should say the learning exchange and the knowledge base. So with that, just a reminder on the offers again on the PTC Creo simulation tools on the virtual training and the MathCAD, as well as, please remember the date on the LiveWorks, PTC LiveWorks event, which is going to be from June 6th through 9th. And a reminder about the Import Data Doctor webinar, wherein you could win a tailor-made driver. All right, so thanks again. Thank you all for attending this webinar. We look forward to seeing you all soon in another webinar. Thank you.